Everyone. So today we will continue with the second lecture of testing and measurement class, and today we will go through scales, transformations, and norms. So firstly we have this construct called raw score. It's basically the number of items scored, coded in a specific manner, correct, incorrect, true, false, etc. So it gives very little information about like how well the participant did in the experiment, or how they did. We cannot really compare their scores to anything when we are dealing with like raw scores. So we need something else. We need either norm reference versus criterion reference score interpretations. So in terms of norm reference interpretations, what it means is that we are just comparing their performance to a norm, to like other people that constitute the norm. So this could be in terms of personality test or IQ tests, like when you are doing, for example, like extroversion introversion test. There should be a norm, like average person that is neither introverted or extroverted, so you could be put in either one of these categories. Or in IQ test there is an average, so if you do better than average you get a certain score, or if you do below the average you get a certain score. So these tests are norm reference. We are looking at the norm, average, or what is considered as normal, and then we are comparing our scores to that score. So in criterion referenced interpretations, it's just about specified level of performance. So it's absolute. It's just like for example, I'm teaching you some subject in math and I'm testing you just to learn if you really understood the subject. So I'm not trying to compare your performance to another thing or anything. I just want to know if you understood what I taught you. So it's just criterion reference. Like you can think of it also like getting your driving license, and you need to take a test that shows that you are you know enough stuff about traffic rules and everything. So it's just criterion reference. Like you need to get above certain point, but it's not about the norm, but it's average, etc. It's just the criterion. So norm and reference groups are pre-selected groups of individuals, and we need like relevant reference groups and samples. So we can do something called national standardizations. These are the kind of detailed notes so that you can understand the topic more deeply. So I'm not going to go through each thing very deeply, like because most likely the instructor won't really go emphasize on them. So normative data changes, so we need current normative data. Like in terms of IQ tests, we saw a significant increase in the 20th century, so that everyone's IQ tests were like they were getting higher and higher scores. So we need to control for that. We needed to control for it and get like more difficult IQ tests, so that people will get lower scores, so that we can compare people's IQs more efficiently. So it's like that. We need like normative data that is current. So we can also use derived scores used with norm reference interpretations. Like we have standard scores. Like raw numbers are difficult to work with, so we can transform them to another unit of measurement or derived score. With normal reference interpretations, we use standard scores are often like they are preferred, and transforming raw scores into standard scores include creating set of scores with predetermined mean and standard deviation that is constant across pre-selected variable. So now let's like kind of see some examples. I think it will like be more clear. Often standard scores are simply linear transformations of raw scores to desired scale with predetermined mean and standard deviation. So as you can see, this is our formulation for getting like standard scores. So some examples to this is z-scores. They are the simplest of standard score format, and they indicate how far above or below the mean of distribution a raw score is in standard deviation units. They are very simple to calculate, and it's their simplified equations can be used thanks to these scores. So like they have a mean of 0 and standard deviation of 1. So all scores above the mean are positive, as you can see, and all scores below the mean are negative. So these scores also involve decimals, and this is one of the reasons why we don't prefer these scores, also because they include the negatives. This is something that kind of creates conflict. Like for example, when we are trying to measure IQ levels, like we can't really get negative scores when we are measuring IQ levels, because everyone has certain intelligence level. People below the mean, like it kind of creates the impression that people below the mean have negative intelligence, or they are like very deficient. They have no intelligence at all, which is not the case. So we need a system that gives us all the time like the positive scores and no decimals, because decimals can be very confusing. And so then what we use is we use T-scores. And z-scores, their mean is 0 and their standard deviation is 1, whereas in T-scores their mean is 50 and their standard deviation is 10. And this is one, like these are two reasons why we prefer them over z-scores. And like in IQ, as I explained, we use T-scores in IQ as well. And not all researchers, like they specify which standard scores they're using. So in normalized standard scores, many variables in psychology are normally distributed, but some are not. So we may normalize the standard scores in these cases. And yeah, like we use nonlinear transformations when we do them. So there can be two reasons why our data is not normally distributed. Either variable is actually not normally distributed, in which case like kind of normalizing and using normalized standard scores don't really mean a lot. It's not really beneficial. But when there are like sampling errors, choice of subject, that is the reason why we are not getting a normally distributed data, then it's good to use normalized standard scores. So there are some examples to this. What we need to focus on is percentile rank, because these are not really focused on in the slides and from the teacher. So percentile rank is like, it's very popular, it's very easy. We are comparing our performance to the rest of the group, and what it indicates is that if you are in the, let's say that you are in the 6th percentile rank, what it means that is that you did either equal or better than the 60% of people. So that's basically what percentile rank means. So yeah, like here's a picture. I couldn't fit it into the slide, so I had to make it very small. So here you can see that it's not like equally distributed, because it's a normal distribution here in the percentile rank. So yeah, it's mostly distributed around the average, around the mean, and through the tiles it gets less and less. There's less people. So they don't give, something about percentile rank is that they don't give interval level comparison, and they're compressed near middle of the distribution and spread out near tails. Yeah, I said tiles, I think that's wrong, I'm sorry, it's tails. Most data around the mean tails are less crowded. That's why it's not really preferred in statistics, but we do, I think, use them in this class. So they're important in this context, I guess. So yeah, I explained this already. So for a normal distribution, our mean, median, and mode should be close to each other. Our distribution should be symmetrical, the crowdedness in the middle part, and less crowded towards the tails. In skew distributions, I think we will go into that later. Okay. So we have grade equivalence, which is norm reference derived scores that attempt to identify academic grade level achieved by the examinee. Like third graders mean raw score is 50, for example, grade equivalent of 3.0, and fourth graders mean raw score is 60, so grade equivalent of 40. So if a raw score falls between two grade levels, testers use interpolation to estimate grade equivalence. Like, for example, 3.0 rough score is 50 and 4.0 rough score is 60. So if someone did 55, for example, they did as well as 3.5 percent, like 3.5 grade equivalent. So yeah, this is something that we can use, but there are some concerns about grade equivalence. Like there is an interpolation used, like academic scales are not really achieved at constant rate, and they're not really comparable across tests or subtests because they don't really increase like this. They increase like this, or they increase like this. So like we cannot really compare true test and subtest like that well. And it is an ordinal level of scale, not interval, meaning that in between 3 and 3.0, 4.0, and 5.0, they're not equal to each other. That's what it means. So they're not really predictable relationship between grade equivalence and percentile ranks, like yeah. And there's a common misconception that, like, for example, Aisha got grade equivalent of 6.5, but she's in the fourth grade. So, like, should she be getting sixth grade math? But also there are other skills that are required for Aisha to take sixth grade math. So it's not just about this. So it can kind of create this misconception in this sense. Grade equivalence becomes standards of performance, but 50% of standardization samples scored worse than the grade equivalent. Like, in order to have a mean for average, there should be people below the mean and above the mean. So 50% of like standardization samples scored worse. So if we just use like, for third graders, okay, then all third graders should get this grade for them to pass this class. But that means that 50% will fail the class. So it can cause these issues. So let's go with now explain criterion reference interpretations. We have explained them briefly, but basically they just emphasize what examiner knows, what he or she can do, not just person's standing relative to other test takers. Like there's mastery testing, when we determine whether examiner has achieved specific level of mastery of knowledge and skill domains. And it's like a all versus none, pass versus fail designation. Like most important consideration with criterion reference interpretation is how clearly knowledge scale domain is specified or defined, not comparing to the group. So like it's just like how much knowledge should a person know when they're getting a driving license? How much is enough is what is important. Like when we are testing our students for the math subject that we taught them, how difficult should the questions be? Like, how difficult the questions should be in order to we make sure that their knowledge is enough. So we need to know that. So do we use norm reference, criterion reference, or both? Like, what do we use? So technically, it's not accurate to refer to norm reference test or criterion reference test, because it's the interpretation of the performance on the test that's norm or criterion reference. So it's not the test itself that is norm reference versus criterion reference. So norm reference interpretations can be applied to both maximum performance and typical response tests. But criterion reference is applied to maximum performance tests only. So because they show examiner's knowledge or skills in the specific domain, and even in maximum performance tests, norm reference interpretations have broader applications, because criterion reference is only like focusing on if they have enough knowledge, if they have enough skills, but it's not really focusing on a lot of things like norm reference is focusing on. And even in achievement tests, norm reference interpretations often cover broader knowledge and skill domains. Test design for criterion reference interpretations, they have narrow focus, and they are able to devote relatively large number of items to measure each object. So test design, I'm sorry, I had to stop for a minute. So test design for criterion reference interpretations, they, as we have talked about it, they have narrow focus. So because they have narrow focus, they are able to devote relatively large number of items to measure each objective skill that are being measured, because we are just like trying to figure out if they have enough knowledge on something, so we can like measure a lot of items in this sense. But in terms of norm reference interpretations, they have broader focus, so we're not really looking if they have enough of knowledge or the skill, or we're looking for something much broader, so they can devote only a few items. So they may devote only a few items to measure each objective and skill, because they have a very broad focus. So when we are developing tests for norm reference interpretations, developers typically select average difficulty items, but when we are developing tests intended for criterion reference interpret, it's not about like how average difficulty is or anything, but it's just about how difficult we need the items to be to measure the participants, the students, the skills or the knowledge that are being assessed. So this is a small like table. If you would like to take a look at it, you can stop the video. But they basically, it's the same things basically. It's not really adding anything new to what we have talked about. So tests can be developed. They provide both norm reference and criterion reference interpretations. So tests can be like using both of them. And then we have item response theory, which is theoretical and technical advances used heard in new types of scores. They're based on item response theory. We have a latent trait, which is like some ability or character that is inferred to exist based on theories of behavior. And as you can see, like each examiner possesses certain amount of latent trait. Like for example, let's say anxiety. Like everyone has a certain amount of anxiety, whether it's very, very low or very high. So yeah, you can see here. So scores based on a IRT model are similar to raw scores on tests developed using classical test theory, but they have distinct advantage. They are equal interval level scores, and they have a stable standard deviation across age groups. So IRT scores, they can be called V scores, growth scores, change sensitive scores. It doesn't really matter, these parts. So which scores to use? Norm reference, criterion reference, or rash based scores? And different types of test scores answer different questions. Like raw scores, they just explain that number of points accumulated by the person relative to the ranking or ordinal scale measurement. And traditional norm reference standard scores, they give comparison to reference group, and they can give also interval scale measurement. In criterion reference scores, person's performance versus design level of proficiency, we are comparing these. And in rush or IRT based scores, there's an equal interval scale that reflects position on some underlying or latent trait. Like, for example, John is administered a reading test prior to initiating intervention or specialized reading methods. So what would each of 4 types of scores tell us about John's change in reading skills? So first off, common standard scores, they would tell us like how has John's reading performance changed relative to starting point of his specialized instruction. Rash type scores would say how did it change relative to the starting point of his specialized instruction, the same way, but it's just it's not on a it's on an equal interval scale. So in criterion reference scores, they would ask, has John's performance in reading reached predetermined level of proficiency or set goal for his instructional progress? So norm reference standard scores, they reflect John's position in race relative to all other roomers at any given time. So rush scores indicate accurately his distance from starting point, but not progress relative to not progress relative to others without knowing their rush scores. So criterion reference score lets us know when Josh had passed specific points on racetrack and reached finish line. So let's go through qualitative descriptions of test scores. They help professionals communicate results in written reports or other formats. Like when we are using like IQ scores, it's difficult to like really like make something like in IQ scores, maybe not that difficult, but still it just kind of gives us certain directions, like about how well they did or how good their IQ, how high their IQ is. So this is the end of the topic basically. Thank you for listening, and I hope to see you in the next class.